Hey, in this video we'll be talking about some advanced features of templates. These are features that we're not really going to go that deep into. I just want to mention them, make sure that you are aware that they're out there so you could look them up or go further into template programming if you're excited about this stuff. So I'm in Visual Studio and I wanted to make a class. I'm going to call it pair. This class is just going to hold a couple of pieces of data, let's say int first and int second, just a pair of numbers, right? So it's sort of like an association between these two numbers. It's grouping them together. I don't know, they could be like a coordinate pair or ID numbers or something, anything related like that. This is just a normal class, and that brings with it the limitations that a normal class has, where these types cannot change. They're always going to be integers. So if I use a template, I could specify a generic type, and I could change that type for these two different variables. And now I'm able to make a pair of type int, just like before. But I can also make a pair of floats. I could make a pair of strings, and whatever. I could go on with this. There's another feature of templates that I could use here if I wanted these two types to be different. I could add an additional type parameter. So let's say type name. Let me change this to U and V. That's not confusing or anything. Okay. So here I can specify multiple type parameters and have this class use those different types in all sorts of ways. So now I have to change my my declarations here to say what both of those types are. Could map a float and another float. They could have a pair of two floats. Could have a pair that pairs a string with an integer. That could be kind of fun. And now I'm able to use these variables because they are those types. ps.first should be a string, so it should be able to say hello. And ps.second is an integer, right? 5. Great. And then I can go on and use them. But this is a very simple example, probably the simplest I possibly could come up with. But you can go much farther with this and make some really useful templates like this. So there are lots of other features that templates in C++ have and can do. Some interesting ones are that you can have template specialization. So you could have functions that do different things with these different types, but then you might want it to act differently depending on the type that you provide. So you may want your class to have a specialization so that it's a little bit different if you store one type versus another. For an example, let's say you have a vector of integers. It makes sense to have just storage for a bunch of integers, an array of integers. But if you had a vector of booleans, a boolean is a data type that can store one of two values, true or false. But it really doesn't take much storage space in order to hold that information, right? It should only take a bit, a single bit. However, computer memory works on the size of bytes. So a boolean in C++ is actually the size of a byte. It takes up an entire byte just to store a 0 or a 1, a true or a false. That's kind of wasteful, but it's for performance reasons. Memory is cheap, where computation, not so much. And if you had a vector class that stored a ton of Booleans, you might start feeling that memory issue there. You might start feeling that using up 8 times the memory of this Boolean, or each of these Booleans, is not worth it. So you could specialize a vector class to store just integers, and inside those integers you can be treating each of the bits of that integer as a Boolean. And so you can kind of condense and specialize and save a lot of memory that way. Just make the class work better for a specific type, just because of that type's details. So that's possible. You can also have non-type parameters. So I don't have to do type name v. I could specify something like a variable here, and then when I go and actually use it, I could specify a value for that variable. Kind of weird stuff, but it does have its uses, and it kind of leans us into this area of recognizing metaprogramming. And metaprogramming, it's its own big topic. People, when they were developing templates in C++, recognized and realized that metaprogramming was possible using the template system. And so they kind of extended templates in order to do more metaprogramming. So metaprogramming at its basic level is writing code that generates code. It's writing at a higher level of programming in order to produce programs. It's pretty crazy, but if you've ever written code and then felt like, oh, I've written this before, or I have to repeat myself over and over writing this piece of code, that's a place where metaprogramming could save you time, possibly. So it's also a lot of details and additional knowledge that you need in order to do metaprogramming effectively. But it can produce some very concise programs that can do a lot of work for you. So you're essentially letting the compiler produce your program based on instructions for how to produce that program. All right, so there's some cool things out there, and this is just a few things that you can do in C++ that you aren't able to do in C#. Because their template system is not quite as involved as C++ is. All right, so I think that's pretty cool. That's all I wanted to show you here. Just be aware of some really cool advanced uses for metaprogramming and templates out there, and I'll see you in the next video.